Here's a video for arithmetic sequences. So an arithmetic sequence is a sequence of numbers in which the difference between any two consecutive terms is a constant. In other words, it is a sequence of numbers in which a constant is added to each term to produce the next term. This constant is called the common difference. The common difference is typically represented by the variable d. So basically what an arithmetic sequence is, it's a sequence of numbers where the way you generate the arithmetic sequence is by either adding a constant term, or you can think of adding a negative number, which is the same thing as subtracting a positive number. So the common difference of a sequence is positive if the same number is added to each term to produce the next term. So if the same positive number is added to each term to produce the next term, the common difference is positive. The common difference of a sequence is negative if the same negative number is added to each term to produce the next term. In other words, we can also say that the same number is being subtracted. So let's take a look at a worked example here. It says, consider the sequence shown 11, 9, 7, 5. The pattern is to add the same negative number, minus 2, or we can think of subtracting 2. It's the same thing. To each term to determine the next term. So 11 plus negative 2 is 9, or 11 minus 2 is 9. 9 plus negative 2 is 7, or 9 minus 2 is 7. 7 plus negative 2 is 5, or 7 minus 2 is 5. So therefore we can say that this sequence is arithmetic because we are adding a common difference, which is negative 2, and that common difference d would be negative 2. So in this case, it says, suppose the sequence has the same starting number as a sequence in the worked example, but the common difference is 4. So remember, in the worked example, it was 11, 9, 7, 5. So if it had the same starting number, that starting number would be 11. But if our common difference is positive 4, in that case, we would be 11, 15, 19, 23. So how would the pattern change? It would be an increasing pattern. And then whether or not the sequence is still arithmetic, since we're still adding a common difference, we're adding 4, the sequence is still arithmetic. The only difference is that common difference is positive, which would make our sequence an increasing function rather than decreasing. So now it says, if possible, write the first 5 terms. So I've written the first 4, 11, 15, 19, 23, plus 4 would be 27. All right, so now we have a variety of sequences. It's asking which sequences do we think are arithmetic, justify our thinking. So in a previous activity in this lesson, you were to fill out the missing numbers. So I'm just going to pick out the ones that are arithmetic. So A is going to be arithmetic. In this case, we are adding 2 each time. So this would be 4, 6, 8. Another one of the arithmetic sequences is D. In this case, we are adding 4 each time. So this would be 0, 4, and 8. And then the last one that's arithmetic is E. In this case, we are subtracting 1.5. So our common difference is 1.5. So this would be 0.5, negative 1, and negative 2.5. So first one, our common difference was positive 2 because we're adding 2. Second one, our common difference is positive 4. And our last one, our common difference is negative 1.5. So we're going to write out our 3 arithmetic examples. So the first one was negative 4, 2, 0, 2, 4, 6, 8. And the common difference in this case was positive 2. Example 2 was negative 20, negative 16, negative 12, negative 8, negative 4, 0, 4, 8. with a common difference of positive 4. And the last one was 6.5, 5, 3.5, 2, 0.5, negative 1, negative 2.5. And that common difference was negative 1.5. All right, so what we can do once we have an arithmetic sequence is we can actually write a formula that will help us determine any term of an arithmetic sequence. So here's how we write an explicit formula for an arithmetic sequence. To get a to the n, or an, which is whatever term you want. So it can be the 5th term, 6th term, 7th term. It could be the 100th term, 1000th term. Well, the way that we write it is we take our first term, which is a1, plus our common difference, with parentheses, and then we do n minus 1, the term number, whatever term we're trying to find, and then we subtract 1 from that. So let's work through these examples. For each arithmetic sequence, we're going to write the explicit formula, and we're going to find the 25th term. So remember, for these ones, we already determined the common difference. The common difference for the first one was, oops, I realize I'm missing a minus sign here. Common difference here was positive 2, right? And our first term in this case is negative 4. So the explicit formula is going to be a to the n, and it's going to be the first term, which is negative 4, plus our common difference, so plus 2 times n minus 1. So there's the explicit formula. And now to determine the 25th term, we're just going to plug in 25 for n. So to find the 25th term, it's going to be negative 4 plus 2 times 25 minus 1. So when we put that in our calculator, well, 25 minus 1 is 24. And if we multiply that by 2, that's 48. So it's going to be negative 4 plus 48, which is going to give me 44. So my 25th term is going to be 44. All right, the next example, we know our common difference is positive 4, and our first term is negative 20. So my explicit formula is going to be an equals the first term plus the common difference, so plus 4 times n minus 1. And now we can find our 25th term. So we're going to plug in 25 for n. So negative 20 plus 4 times 25 minus 1. So again, 25 minus 1 is 24. So then we're going to multiply 24 times 4, which is 96. So we have negative 20 plus 96, which is going to be 76. So my 25th term is going to be 76. All right, so then this last one here, we have our common difference, which was negative 1.5, and we have our first term, which is 6.5. So my explicit formula is going to be an, the first term, which is 6.5, plus my common difference, or we could just write it as minus 1.5 times n minus 1. All right, now to get my 25th term, we're going to plug in 25 for n, so 6.5 minus 1.5 times 25 minus 1. So since we're dealing with decimals here, I'm just going to use my calculator for this one. So I'm going to put this in my calculator exactly how I have written, 6.5 minus 1.5, parentheses, 25 minus 1. And that's going to give me negative 29.5. So my 25th term is going to be negative 29.5. All right, last ones here. It says for each example, determine if the sequence is arithmetic. If it is not arithmetic, explain how you know. If it is arithmetic, explain how you know. Then write the explicit formula and find the 18th term. So looking at example 1, to determine if something's arithmetic, we need to see if we're adding the same amount or subtracting the same amount. So this looks like an increasing function. So to go from 2 to 8, we know that we have to add 6. But then to go from 8 to 32, let's see, 32 minus 8, you have to add 24. So already I know that this is not arithmetic. And our reasoning is because it does not have a common difference. So there is no common difference. All right, let's look at example 2. So 15.5, 8.5, 1.5, minus 5.5. So in this case, it looks like it's decreasing. And to figure out how much it's decreasing by is we can subtract our first numbers. So 15.5 minus 8.5, it's going down by 7, so minus 7. So now let's see if the same pattern follows for the next one. If we do 8.5 minus 7, we get 1.5. So far we have a common difference. Let's just check one more time. 1.5 minus 7 gives me negative 5.5. So in this case, yes, it's arithmetic, because the common difference is negative 7. So now let's write the explicit formula. So we know that D equals negative 7, and we know that our first term is 15.5. So my explicit formula is going to be 15.5. My common difference is 7, so I'm going to write negative 7, sorry. Minus 7 times n minus 1. So there's my explicit formula. And then it says that we're going to find the 18th term. So the 18th term we know is going to be A18. So it's going to be 15.5 minus 7 times 18 minus 1. So this is going to be negative 103.5. So the 18th term is negative 103.5. All right, so now let's take a look at some of the homework problems. So in this set of problems, we're determining if the sequence is arithmetic. If it is, we're finding the common difference in the next 3 terms, and if not, explain why. So looking at number 2, it seems like this is an increasing function, so we want to see what do we need to add to get to 45. So to do that, we can do 45 minus 36, which is 9. So it looks like we add 9. So let's see if that pattern follows for the remaining terms. 45 plus 9 gives me 54. So far so good. And let's just check one more. 54 plus 9 gives me 63. So it looks like we do have a common difference. So yes is arithmetic. My common difference is going to be positive 9. And then my next 3 terms, so 63 plus 9 would be 72. 72 plus 9 gives me 81. And 81 plus 9 would give me 90. All right, so for this set of problems, it says all the following sequences are arithmetic. For each one, write the explicit formula, then find the term named in the problem. So looking at number 5 here, we have a sequence that's negative 18, negative 23, negative 28, negative 33. So this is a decreasing function because we know that our numbers are getting more negative. To go from negative 18 to negative 23, we have to subtract 5. From negative 23 to negative 28, we subtract 5. And then we keep subtracting 5. So that means my common difference is going to be negative 5. So my explicit formula, my first term is negative 18. My common difference is negative 5. So I'm going to write minus 5 times n minus 1. And now I'm going to use my explicit formula to find my 37th term. So I'm going to plug in 37 for n. So it's going to be negative 18 minus 5 times 37 minus 1. So that's going to give me negative 198.